When you enter the simulation, you will want to check the three boxes: graph values, labels, and intensity. This should give you access to all the values that you want to put in your data table. You should see the value of the wavelength of the peak in micrometers, and the intensity appears under the check boxes in watts per meter squared. The temperature values will appear above the thermometer as you move the blue arrow from bottom to top. You also have some magnification buttons for both the horizontal and vertical axis if you need more refinement or values along either of those axes. Since it is likely that you will use Excel to graph your data, you might consider entering data in the data table in a form that Excel can work with. The temperature data is in Kelvin, so values that you collect of those should be fine as entered in the data table. A micrometer is the unit listed in the wavelength column, so enter the values appearing under the horizontal column as they appear. These can be adjusted in Excel later. The intensity values will be listed in the simulation in traditional scientific notation, but Excel uses E formatting to express numbers in scientific notation. So it might make sense to express the intensity values in that format when you put them in the data table. You're going to collect 20 temperatures that cover the entire range in temperature. Each time you pick a temperature, record its value, the value of the wavelength, and the value of the intensity. Once you have filled the data table, you are finished collecting data. If you copy your data tables into Excel for each part of the lab and you made the adjustments suggested, then there is little that you will have to do in Excel to get the graphs. For part 1, Wien's law involves temperature and wavelength, so copy those two columns into Excel. Make sure the temperature is in column A and wavelength in column B, so the temperature appears on the horizontal axis. You may want a third column after the wavelength column, in which you take each of the values in the wavelength column and multiply them by 10 raised to the negative 6. Your wavelength values are now in meters. Plot wavelength versus this column. Your initial graph should be curved. Look at the expression of Wien's law with wavelength isolated on the left. This should tell you what you need to do with your temperature values to get a linearized graph. For part 2, you want temperature on the horizontal axis again and intensity on the vertical axis. Assuming you put your intensity values in E format in your data table, you should be able to get a graph, which again will be curved. Look at the expression for Stefan-Boltzmann law. This should tell you what to do with the temperature values to get a linearized graph. The slope value for each of your linearized graphs should be compared to the constants in each of the equations. You could have Excel get the percentage error for you, or you can do it using a calculator. But this calculation should appear as a separate calculation page in your write-up. What you will submit for grading. The completed Word write-up should include a complete data table and answers to the questions. As I've indicated, both initial graphs will be curved. They should be submitted along with the linearized version of each. All 4 graphs should have fits to the data, the equation Excel provides for that fit, proper titles, proper labels on each axis, and in the case of any fits that tend toward the y-axis, an extension to the y-intercept. A calculations page should also be included with the percentage error calculations done as stated in the analysis section.